Okay, guys, I'm going to try to make this pretty short. So if you need to watch some of it in order to understand all of it, that's fine. Or you can come into class and ask questions, and I'll help clarify any of this information. So this is lesson 2.4, unit 2, lesson 4. We're going to evaluate square roots and cube roots. The essential question you should be able to answer by the end of this is, how do you evaluate cube roots and square roots? Pretty straightforward, right? Okay, so our vocab is square roots. We've already gone over that, so you need to review information from lesson 2.2. That'll help you get looking back at other stuff that you haven't looked at. Cube root. I figured the easiest way to show a cube root is to go through and show you an example. When I looked at the definition, it was pretty confusing, kind of like when I looked up square roots. So a cube root is when you have three numbers, you multiply, let's take 3 for example, 3 multiplied by 3 multiplied by 3, 3 times 3 is 9, times 3 is 27. So if we're looking at the cube root, we end up going through and saying the cube root of 27 equals 3. In other words, what number can we multiply by itself 3 times to get the number underneath the cube root? Okay, guys? The first 3 perfect cubed roots are 1, 8, and 27. If you notice, the cubed root of 1 is cubed 1 multiplied by 1 multiplied by 1, which would equal 1. 8 is 2 multiplied by 2 multiplied by 2, so it's 2. And then 27 is what we've already done up here, 3 multiplied by 3 multiplied by 3, so the cube root of 27 is 3. Okay? Now I'm going to show you how to find that in case you have a problem. I'm going to show you the short version, and then when you guys hit some XLs, I expect you to come in and ask me about it. We'll work out those problems together. So here's what we're looking at here. So these are the examples from example 2. Okay. Now, when I went through, and there's a D also, but it's the cube root of 1, which you should already know from the example I did there. You're going to know this cube root also, but I want to show you guys how to actually find it. So if I'm going through this, what I want to do is do the prime factorization. Okay. In other words, let's find some numbers that I can multiply together to get 27. The first ones that come to mind, of course, 3 and 9. Okay, so we're doing the old trees, right? Then I go through, what can I multiply to get 9? 3 and 3. 3 is a prime number, so I can't go back down any further than that. I circle these 3, right? That's 3 of them. That's the cubed root, so 3 is our answer. Okay? I can do the same thing with this, but notice the difference. This is a cubed root. This is a squared root. If there's nothing there, that means a square root. The first thing that comes to mind when I multiply this is 5 multiplied by 5. That's 2 of them since this is the squared root. So my answer here is 5. Same thing here, squared root, multiply 81. Now with this one, I could go 9 multiplied by 9, right? And this actually has a quad root, in other words, 4, because we go 3 times 3 and 3 times 3. But I can stop right here because we're just looking for the squared, and I just need 2 of them. And so my answer here is 9. Okay? Okay, so that's the example that they didn't give you the answer for on number 2. The other ones are pretty straightforward. This lesson isn't that bad, so you guys should be able to get through it fairly quickly. What I did want to go over was quiz number 3. And I know this looks like a rectangle. It obviously is. I'm not very good at drawing a square, but it's supposed to be a square. Okay? And the question asks, if you were to put ribbon around an area that is 144 square inches, how much ribbon would you need? So what they're actually asking you to do is do the square root of 144, because it's supposed to be a squared, right? The square root of 144, if you know your multiplication tables, is 12 by 12, right? 12 is it. That means it's a 12 by 12 by 12 by 12. So if I were to string ribbon all the way around this, I would simply go 12, oops. Oh, let me erase that. I would simply go 12 multiplied by 4, which would equal 48 inches. These would be linear feet instead of area because we're just going around the outer edges, which is linear. Okay, guys? So that's it. Pretty quick lesson. I'm trying to go a little quicker so you guys can get time to be able to do other stuff. Make sure you take good notes, come to class. Have questions for me, guys. You need to keep up with this. We're going to be going really quick, and you're going to need to stay after school or whatever you need. I'm willing to help you with, but you guys need to put forth the effort too. All right. We'll talk to you soon. Bye.